Check 1, 2, audio check. Let me know how I sound, especially in relation to the music behind me, and I will see you all with my face and my voice in about 2 minutes. Oh, 1 more minute, please, everybody. Okay, I'll be here in 1 minute. Hello, everyone, and welcome to a Saturday afternoon episode of the Coding Train Live, coming to you live here from Brooklyn. Sorry for that little glitch. I had to take an extra round of this 1 minute song. I was having a little difficulty getting some things set up here. So I am thrilled to be here with you today. If this is your first time watching, welcome. One of the things that I like to do is offer a little prompt to hear from folks in the chat. Nothing too extraordinary today is my prompt. I would like to know, what did you have for breakfast today? So I know it's 1 p.m. Where I am in the Eastern time zone, but it could be any time of day for you, wherever you're watching from. So maybe you had breakfast earlier today. Maybe you're about to have breakfast. What are you having for breakfast today? Let me know. It's fun to see the flurry of activity in the chat. It gives me a sense of who's watching, where everybody's from, and what kinds of things I should think about eating for breakfast in the future. All right. So before I forget, in case you think that I'm organized and have any sort of plan, not really. But before I start rambling too much and forget, and I'm not sure what is going on. I just had a cookie. That's a little snack, and there's a little piece caught in my mouth. I see eggs and bacon in a bagel, cornflakes, a cup of coffee, cake and coffee, bread, toast. Oh, wait, whoa. I saw something. What I'm always curious about is ackee and saltfish with fried dumplings, says Shaquille. Where are you from where you had that? I am fascinated and by savory breakfasts and places and cultures around the world where you eat what is commonly thought of in my world as a lunch or a dinner kind of food, but for breakfast. A dosa with tea. Last night pizza microwaved. Pancakes. By the way, I am not the best cook, chef, baker, maker of food items in the world, but I do have a specialty. Pancakes. My children can attest that my pancakes are excellent. I like to make them with a whoa already. Welcome to Mike. You have just joined the Coding Train. What have you won with your membership of the Coding Train? Well, my everlasting undying gratitude. The fact that your name pops up in green on my screen over here and I can see it. Mike, are you even watching right now? What did you have for breakfast? But we must find you a random number. Now, there is an interesting question here, which is, last time I live streamed, I had a lot of plans for this Discord bot that was going to help assign random numbers and create random walk patterns and all sorts of things. I have no idea if I have any of that. I certainly didn't do any work on it. Lots of other things are going on. So I will just return to my book. And boy, I had a life-changing moment last week on the live stream where I learned something about this book, which says 1,000,000 random digits. Now, I might say that this book was misleading me, but it was not. In fact, it was quite clear. It's written right here. 1,000,000 random digit. What is a digit after all? Then one single number, a character, a single character that represents a digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I foolishly read this in my mind always as 1,000,000 random numbers. Now, you could also say that there are 1,000,000 random numbers in this book. But I always thought of each random number, and let me see if you can see this. I don't know. It's divided, if you look at any given page, as in groups of 5 digits, meaning a 5-digit number or a number between 0 and 99,999. But there are only 200,000 of those because there are 1,000,000 digits. 1,000,000 divided by 5 is 200,000. So I have something new in my thinking, as my desire is to give out in this world 1,000,000, a random number for everybody. That's my dream in life, is for everybody in the world to have a random number. I don't know. That's kind of like, I think there's a problem with that, because really people should have names. And they should have names that feel meaningful to them, that you feel a certain sense of when you're called by that name. There's an intimacy, a friendship there. And I don't know, I think maybe the whole idea of everybody having a number is problematic. So take that out, take that aside. I love random numbers, and it's a fun little thing we do here. When somebody joins, I give them a random number. It's a gift, a little friendly gift. It's like a random number with a heart from me to you. And I sort of flip through the pages. And ultimately, though, I'm giving you an index into this book, because then you will have your own pseudo-random number sequence of all the other numbers that follow, which you could generate an algorithmic pattern that is the same every time with that pseudo-random number sequence. Woo! So, Mike, welcome to Passengers. Your random number is on page 141. It is row 7020, and it is column 0, 1, 2, 3. And the number here, and I no longer am going to think of these as numbers, but as sequences of digits. Your 5-digit number is 92380. Ultimately, I spent a lot of time doing a lot of math trying to figure out how long it would take me to read this entire book. And I'm starting to think that might be a bit more realistic than I thought. Like, could I do a live stream, right? If there's just 1,000,000 digits and I can read them like this, 80043, how many can I read in 1 minute? Ready? Somebody set a time. Oh, hold on. I'm going to set a timer here. I'm going to set a timer. This is, by the way, the thing that I was trying not to forget was to thank the sponsor of this live stream, Curiosity Stream. I'll do that in a minute, but I'm on a little tangent here. I can't get off this random number reading calculus train. Where is my stopwatch? Timer. All right. We're going to start at 1 minute. I'm going to start at the very beginning. I'm going to try to read it. Should I try to read it fast? Or I'm going to read it at a regular pace. Because I think if I'm going to do this whole book as a full live stream, you know, when I hit 1 million subscribers. Oops. What about if I hit, when I hit 1 point? Oh, I already hit that also. Oh, well. Here we go. Ready? And 1 minute timer. Go. 1-009-732-533-76-520-113-929-749-452-04805-375-420-04805-64895-74296-28 24805 24037 20636 10402 00822 91665 08422 68953 19645 09303 23209 02560 15953 34764 35080 33606 99019 02 0252909376 3831131165 88676 74397 0443627. How long does this go on for? It's called By the Seaside. I didn't repeat. Oh, that's amazing. Okay. All right, everybody. Stop. I've completely forgotten where I got to. Could anybody please in the chat tell me what was the last sequence of numbers I read? I have no idea. Like, I have literally zero idea. While I'm waiting for you to tell me, I'm going to take a moment, spoiler alert for today's topic, to thank today's sponsor, Curiosity Stream, launched by media visionary John Hendricks, who founded the Discovery Channel. Curiosity Stream is the award-winning destination for documentary films and TV shows covering every topic from space exploration to adventure to the secret lives of wild animals. And actually, Abe, thank you to Coding Train viewer Abe, who recommended 2 things for me to watch. I've been making my way through Dr. Hannah Fry's series about maths and data. Man's First Friend. I have a dog, Gloria Pickle, whom I love very much. And there's a whole documentary film about dogs all around the world in different cultures and the history of dogs and humans together. So if you're interested, you can sign up in the link that's in the chat and in the description and on the screen. And you'll get a 26% discount on the annual HD plan. By the way, guess what? That's $14.79 for the entire year. And also get access. Oh, this is kind of like I'm bearing the lead here. You get access to the video streaming service Nebula, which is a streaming service that I'm a part of, along with many other YouTube creators. There's originals on there. There's Nebula Plus content. Find a lot of other YouTube channels that you not even aware exist, and then watch them on Nebula when you sign up for Curiosity Stream using the link on the screen and in the chat. So again, the Nebula itself, I think I forget what the price is, but it's some amount of money per month, and you get that for free along with along with Curiosity Stream. All right, did somebody tell me what number I was on? 0443627. Okay, let me find that. Anybody have a magnifying glass for me? Oh, my vision. These, by the way, are progressive lenses, and I was so thrown off by the way the world looked when I first got them. Now I'm totally used to them, but I think I need them to be dialed up a little bit because I'm having trouble reading again. All right. 0443627. Where could that be? 044. Oh, this is the worst. Please hold. Oh, I found it. 0443627. Okay, I found it. That didn't seem like I made of it. So I read 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 50 digits, 100 digits. let's just round it up 100, 150. Let's just say I read 200 digits in 1 minute. Does that seem reasonable? 10, 20, 30, 40 of these groups of 5 times 5 is 200. So 1 minute, if it takes me to read 200 digits, 1 million digits divided by 200 is 5,000 minutes, which is about 83 hours. All right. I still don't think it's very much more realistic than when I thought it was a million 5-digit numbers, but 83 hours is still like 3.5 days. I don't know. Maybe somebody can just fact check my math there. I got to move some things around. Oh boy, I've got a thing going on over here, a thing going on over here. I'm not in the right place. Okay, clear, local chat. All right. So what have we got in store for you today? So first I'd like to do some kind of like updates. I mean, it's not really breaking news, but I'll play my breaking news. Coding Train breaking news. So, Coding Train, what's happening on the Coding Train? First of all, if I'm live right now, yesterday I released a guest conductor video with Lily James from the Twirling Tech Goddess. It's a really wonderful YouTube channel. Let me just see if I can just go over and look at the full channel for a moment. And you'll see that Lily does a lot of work with 3D printing and fashion, hardware. Like, I'm always looking for guests to feature videos on topics that I don't really touch on. Lily has a really fun, unique personality. She has a twirl test for her technology, has a lot of energy and enthusiasm, a nice set of subscribers here on YouTube, but could use a little Coding Train boost. So if you have a chance to check out Lily's channel and subscribe, I'm a big fan, and I think it would be great to show her a little bit of love. So, and John is suggesting in the chat, record yourself saying 0 to 9 and build code that plays your audio. Yes. So that would definitely be a great project for a live stream someday. I'm having a bit of an issue, which leads me to kind of the topic for today, which is that, and I need to move this out of my way. Oh my goodness, I have so many things in weird places. Sorry, I'm kind of, I hate to say this because I probably shouldn't alert you to this fact, but I'm trying to sign up for something related to something I want to get for my kids. I'm in like an online queue kind of thing. And so I might have to take just like a 1-minute break to like get something real quick over here when it's my turn. So if I'm a little bit distracted today, please bear with me. And Boy, whose name is very aptly named, whose YouTube username Boy, which maybe is your real name, I'm not sure, loves the Boyd's Coding Challenge, and that's what I'm doing. Prathamesh says, I am here. What did I miss? Where's my absolutely nothing sound drop? Absolutely nothing. Sing it again now. Just me talking, trying to count up to 1 million with random numbers and doing some useless stuff. But one of the things that is, I suffer from trying to do too many things at once with the Coding Train. Have sort of a fun coding live show, which is what I'm doing now, which is really just me rambling because I don't have time to prepare and do segments or have lots of things organized for it. I use the videos for actual curriculum that I am teaching in courses at NYU. That's really where almost all of my focus is right now, in teaching the course The Nature of Code at NYU for a group of 31 students. And so I am refreshing and redoing all of the videos. Probably a better place for me to look at it is here. And you'll notice that it stops with chapter 3. And you might be wondering, how are you possibly getting through a semester only having the content up until chapter 3? Well, good news for you, Coding Train viewers. I have already finished the videos for chapter 4. And my students are watching them now. In fact, if you are a Coding Train member, I might have shared with you some sneak peeks of them. But I'm still working on the descriptions and the code and the thumbnails. So those will appear. Hopefully they'll come out like boom, boom, one per day this week, I'm hoping. Because I should be able to finish those up with all the folks that are helping me. With that, thank you to Mathieu and Violet and Sai and Kobe. I don't know, naming random people who are helping with Coding Train things now, realizing I'm going to forget somebody. So stay tuned. And I have begun the process of recording the videos for Chapter 6, Autonomous Agents. And I have already recorded, but they have not been edited and put together, the first 2 videos for this chapter. So I'm getting a little bit ahead. Another news item here, and I'm totally remiss in remembering to think about this since last week. But I really, it's important to me to do at least a video for Pi Day, which, what's today's date? I can't figure out what today's date is. The 6th of March? It's soon. It's 8 days away. Is that next Thursday? Next Friday? I'm not really sure. No, next Saturday is the 20th. No, that's the 3rd. No, I've got more time than I think. Whew. It's a Sunday, right? Sunday would be Pi Day. Oh, maybe I could just... No, I can't do a live stream next weekend. Maybe I could... I don't know what I'm going to do. But I would like to record a video about Pi Day. And I've got a couple suggestions here. Oh, wait a sec. What happened here? Oh, hold on. Please hold. Intermission for just 2 minutes, okay, everybody? I'll be right back. Oh, but put your ideas for Pi Day in the chat or what you ate for breakfast, because I kind of missed a lot of those. I'll be right back. I swear this is going to be less than a minute. I'm back. See how fast that was? You didn't miss anything. I lose all my viewers. All right, so I'm looking over here. So I'm not going to spend any time on this. I'm kind of into this cofactors random number idea. Oh, I can't remember whether I thought of this, but Simon gave me some, or whether Simon thought of it, or who thought of it. Simon definitely gave me some good advice about this. The pendulum, yes. I'm really into the idea of creating a pendulum and then using computer vision to track the amount of time it takes. Let's just look at this suggestion directly. Measure out a physical 2.45 meter long pendulum, then use computer vision to calculate where it is. It should take around pi seconds to complete one cycle. All right, I have to admit something. I am kind of very, well, how should I put this kindly? I'm a klutz. I'm very inept when it comes to mechanical things, whether it's hardware, tools, crafts. I'm just terrible at all of that stuff. So it might seem ridiculous, but the prospect of actually making this pendulum is quite daunting for me. I don't even know where to start. Like, do I just need string? How do I tie the string to the thing, the bob at the bottom? What should I get for the bob? So I welcome your suggestions for what kinds of materials I need. A YouTube video that has a nice tutorial for how to make the pendulum. I don't know. Any suggestions, please put them in this GitHub issue that was started by Simon. All right, I don't want to spend too long on this. I hope that, sometime early next week, Monday or Tuesday maybe, I can record a video and then have it out on Pi Day. We'll see. I've got a lot to do. I gotta keep up with the videos for this course. So one of the things that the primary thing that I want to use today's live stream for is to work out some steering force example code that I have not yet included in the Nature of Code book. Whether I would use that as an exercise solution or another additional video tutorial, I'm not sure, but this is a nice opportunity for me to expand the material that I have. So if I were to go to, I think, the Nature of Code examples-p5.js and go into chapter 6, I would see that I have these steering behaviors. Crowd path following, let me leave that one aside for a second because that's an exercise. There's no tutorial or part of the book on that. Seek, arrive, stay within walls, which is one that I've made up. It's not on the Craig Reynolds in the sort of original Steering Forces paper, which I will bring up in a second. Flow field, path following, separation, and seek, and then the ultimate example of everything put together, the flocking system. And I have covered a lot of this in coding challenges and in older processing Java video tutorials. I'm rebooting all of that right now. Very excited about it. I am householding. I wonder who this. I'm just like no, I'm not gonna look. It's just funny. Like householding, I think is maybe what's meant here. Maybe I put that in there as housekeeping. But thank you to Alain Gourves for your wonderful pull request that was accepted here. Maybe there's a nice translation from the perhaps French, where that makes more sense. All right. So let me not spend any more time. And Chris is pointing out it will be tricky to hang a 2.45 meter pendulum. So I could probably do a shorter one in this and then do time multiple, right? If it's half of it, would I time like two cycles? Anyway, I will work that out. Oh, somebody will suggest for me. Yeah, shorter would be great. And what am I doing here? Steering behaviors. Yeah. Okay. So this, if you have, where to start? Here we are. This is where I want to start. If you are not familiar with this work, and you like the kinds of things that I explore on the coding train, you're missing out. Maybe not everybody in the world is missing out on this, but you're a viewer here of the coding train. If you are a beginner to code, if you found this channel and are watching because you're just starting on your coding journey, some of the elements described, some of the code required for the implementation of this is pretty sophisticated, and so you might hold off to return to it later. But the concepts here, I think, are quite accessible and understandable. And it's sort of like a core, the principles described in this paper, which is from the Game Developers Conference 1999. I would like to know right now, this is where I really need to finish that stupid live poll thing, because I could just throw it up right now. How many of my viewers, or the viewers right now of this live stream, were born in 1999? I was definitely alive then. In fact, I hadn't started to learn to code really in 1999. I started to learn to code about 2001, but I learned quite late. I can't do the math, but I was born in 1973. So you do the math. This paper came out after I graduated from college, and I'm assuming a lot of you were not yet born. It's an incredible paper, and it forms the basis for so much that you see today in computer graphics, in animation, in games, in Hollywood cinema, if that's the right way to say it. It's so foundational, and it's also a big source of inspiration for many creative coding artists. Casey Reese, one of the creators of Processing, to name one. I don't know, I got a piece of hair somewhere on me. Oh, this beard. I did not have a beard in 1999. I was a fresh-faced youth back then. Oh, it was a different time. All right, 1991, 2000, 1990, 1990, 1988. All right, we've got somebody who started coding in 1988. Mwah! What were you coding on in 1988? And I can't read your name because it doesn't use my knowledge of other non-English language character sets is very small. Sad Sanko is older than me. Danielle was 17. Um, I'm lovely. I love reading the chat. This is fun, really fun for me to see. I always like to try to understand the viewership, and I'm always surprised and really pleasantly surprised at how young. And again, I hear from everybody. I hear from people who are older and retired and learning to code or had a long career of coding who are enjoying some of the stuff that I'm doing and provide helpful feedback. I hear from people who are very young in their teens who are learning to code, but the bulk of the viewership is of that sort of high school, college, early 20s age, at least according to YouTube analytics, which I always find fascinating because I feel more and more like an old. I was trying to put this in a gracious way, but just like an old, I guess. All right. Somebody mentioned something to me yesterday, which was some kind of social media online thing, and I had no idea what it was. None whatsoever. I can't even pull it up. I was in a Twitter space with Scott Hanselman, who you should check out Scott Hanselman's YouTube channel. I kind of been a little bit obsessed with the Clubhouse app. If anybody wants to connect on there, you can follow me on Clubhouse. Okay, this is cool to really read. Started coding on a ZX Spectrum. I'm gonna have to go back and read all these chat messages. This is amazing. This is amazing. Apple II Euro Plus of my dad's in the late 70s. So the first computer that I ever wrote any code on was an Apple II Plus. If anybody's a fan of the TV show Stranger Things, I think the kids in that show are like 10 years old in 1983, approximately. That's exactly that show speaks to me so. Like I get all the feelings watching that show. I probably had a different. I'm not saying I was like those kids, or certainly I didn't experience the supernatural in their way. But Dungeons and Dragons, Ghostbusters, all of that stuff, walkie-talkies, bicycle riding, all that stuff is really speaks to me. But I think I've talked about this before, but I did a science project in elementary school where I tried to do something about perception. And I think I wrote some code in BASIC to blink a light on the screen or blink characters really fast and then ask the viewer if they could write them down and remember them. I have to go back and find that. I think that 2 Plus is still in the attic where my parents live in Baltimore. I'm gonna have to find that someday. Oh, I'm so into computer history and computer graphics history. It's a little bit. I'm off. I gotta work on these examples. Keep me on track, people. Keep me on track. Keep me on track. Okay. Ashik is saying, please bring back Cabana and or coding challenges. I hear you. I really hear you. This is basically the most common feedback I get. I miss the coding challenges. I don't know if people actually say they miss the Cabana, but just those coding challenge videos. I will try to get back into more project oriented things like that. So stay tuned. But unfortunately, fortunately or unfortunately, this is my hobby in many ways. The coding train. I'm going off. I'm talking to, and I do have a lot of responsibilities to my students, and the tutorial videos end up taking precedence because of that. Okay. So back to this paper. All right. So this is what I was looking for, this particular list. So if anybody wants to take notes here and share this with me afterwards, super would appreciate it. I'm sure Simon is already on it. But this is the list of all of the behaviors divided into individual behaviors and combined behaviors. So my personal goal is to have a P5JS and processing example for every one of these. And I have seek, and I have flee, and I have wander, and I have arrival. I have path following, I have flow field following, I have crowd path following, I have flocking. So I don't have pursue and evade. That would be an easy one for me to do today, but I think I might like to try for something a little bit more ambitious. I do not have obstacle avoidance and containment, which have some similarities to them. I do not have wall following. I do not have leader following. I do not have unaligned collision avoidance. And I don't have what is my favorite steering behavior of all time. Queuing! and a doorway. It's like the greatest steering behavior. You gotta see it. And here's the thing that brings me immense sadness right now. Ordinarily, I would be able to just click on any of these, like queuing, and I would see the animation happening right here. In fact, I think if you go to, and I apologize, but this is who I am. I can't help it. I'm gonna go all the way to the old videos that are from. I actually don't know when I recorded these. I uploaded them to YouTube in 2015, but I kind of think that a lot of these were recorded in 2012. But if I go through into this video here, at some point I bring up the web page, and it's coming. There it is. So this, by the way, look at young me there with like weird bad white balancing and very red face. But like compare the amount of gray hair and the bald spot to there. Glasses are pretty much the same, but I think this might be from almost 10 years ago. I don't know if anybody could. I wonder if somebody could watch through these videos and if like the time pops up somewhere or the date, because I'm pretty sure this is just when I happened. I definitely recorded these before the year 2015. I was not even, yeah. Anyway, that's just, I would love somebody to investigate that for me. But here you can see the queuing behavior playing out, and I can make this full screen. And so I love this steering behavior. And these were all created by Craig Reynolds as Java applets. The code, I believe, is closed source. Don't quote me on this. I could be wrong. But if I understand it correctly, Craig Reynolds was working on these behaviors while working at Sony Entertainment. So all of the algorithms and the descriptions of those algorithms are all very well defined in the paper that I'm about to click on here, explained in great detail, but the code was closed source. But there's many implementations of them. I'm certainly not the first to implement them. I might be sort of more visible now in terms of having this YouTube presence, but there's an OpenSteer library from C++, lots of other examples of people implementing these behaviors. So I'm really saddened by the fact that so a year ago, because the year ago is the last time I looked at this, I was able to get these to run as Java applets on the page. First, I would see an error, and then I would go through and change. I think I ended up using Firefox or a different browser to make sure Java was running and the plugin and change the settings. But I think, I don't know if this is related to Flash being completely disabled, but I don't know whether it's that the actual applet files have been removed from the server or that the browser won't even bother to try anymore. But it's very important to me that this work is preserved. So one of the things that I would really like to do, and I would love help with this, is to, at a minimum, download all of the jar files. Maybe I could just investigate this really quickly. I've been in touch with Craig Reynolds before. Doorway.class. So this is really the question. If this is the compiled Java code. So, there's all sorts of decompilers we could use. I'm not so interested in that. I don't need the code to be decompiled and published if it's not meant to be published. I would just like this applet to have a place to be run and people could watch it and look at it. So let me see if this will download. Did it? No. So it would be right here in the same directory, right? So I think it's been removed. Doorway.class. That's not going to get me anything. So if somebody could help me try to find these, and I can try to get in touch with Craig Reynolds. I believe he's on some social media platforms, and maybe he'd be willing to share them. I would like to build a website, maybe just capture them as screen recordings, and then build a website where people could watch them. I think that early work that no longer runs in current systems, it's really important to preserve that work and that history. So yeah, if anybody wants to help with that, hit me up on the Coding Train Discord, on Twitter at Schiffman. You could say it in the chat now, but I most likely will miss your message. Oh, you know it's because I'm in the view source. Okay, great. Who is it who just said that? Remove view source. Thank you. I would remove view source. Yes! Have you ever seen anybody so excited to download an old Java class file from over 20 years ago? Okay. So I have this. Oh boy, I shouldn't go down this rabbit hole. I have this class file. How could I run it? I'm trying to think. It's meant to be run as an applet within a browser. I mean, there's no way that just like it's not going to create a window instance for it if I like. Part of me wants to like do this. Oh, you can't see what I'm doing. Apologies. Oh, am I in downloads? Okay, wait, I have a Java runtime installed, but this won't work. It has to be a jar file that'll open a window. Java applet doorway.class. All right, hold on. I have a JDK installed. What's going on? Is it because I'm on a user account? It must be because this is my like work laptop that I do everything on, but I log into a completely different user while I'm live streaming so that I don't, I do this anyway. I'm not that well set up, but I'm constantly sharing, API keys and things like that. What was it? Java-applet. Wait, what was it? Eclipse. I could try using Eclipse. Java-applet. That didn't work for me. All right, I think maybe this is going to send me down too much of a tangent right now. I will investigate this further on my own and take suggestions, and like make sure I have the right JDK and all of that installed. But I don't want to take up all of your time, as interesting as it might be for all 405 of you watching. I think probably it's more useful for me to go now to the code stuff that I want to do. And just so you know, I'm going to be here till about 3 p.m. Eastern, which is an hour and 15 more minutes. I'm going to take a break in about 15 minutes. I'm trying to be much more strict about my live streaming time. Usually, my kids are doing an online baking class, but there is no baking class today. And usually that would mean they're just downstairs playing Minecraft or Roblox, but they're actually outside taking a walk. Not on their own. They're with another adult who happens to be my spouse. But I would like to go and join them. Hopefully they'll still be out in an hour. And so, to be honest, I would have not live streamed if I knew that was the plan, so I could go and do that with them. But I'm very glad to be here with you right now, and thankful to the Curiosity Stream for sponsoring this, because it really helps me be able to do so much to be able to be here and live stream. Okay, please answer chat questions. I really try. Prathamesh says, let's see if this still works. I went and took a shower since I last messaged. What did I miss? You just want me to do once again. Absolutely nothing. Sing it again now. Okay. Thank you. That's been my live stream for today. See you all next time on the Coding Train. All right. Let's close a bunch of this stuff. Okay. I don't need all this open. All right. So I think that I would. Let me bear with me. Log in here. Coding Train. So the most recent video tutorial that I have recorded that it's still a week or two away from coming out, is just a video that goes through the foundational example of a steering behavior. And that behavior is the seek behavior. So you can see this little triangle thingy is trying to seek this target as I move it around. And there are some parameters I can play with, like a maximum speed and a maximum force to change its ability to steer. So this is where I want to start with, the idea of having a vehicle that calculates a steering force based on a principle of determining a desired velocity, taking the difference between its desired velocity and its actual velocity and applying that as a force. I would love to talk through all of that right now, but that is what I did in what will be a 10 to 15 minute video that will come out later. And I have also talked through all of this, I believe, in 2 previous videos if this topic interests you. Steering coding challenge, coding train. So coding challenge number 59. Steering behaviors, I kind of went all through all this in a coding challenge. This was done quite a while ago. And then also I have done flocking, and I've done evolving steering behaviors. I've done a lot of stuff with steering behaviors, but I'm redoing the sort of like core foundational videos. And there we go. Coding challenge 124, the flocking simulation. So those would be ones if you want to do okay, and I have a coding trade answers your questions for 15 minutes. Yes, that is a good suggestion. I try to do that sometimes like at the end of every live stream, but I do a terrible job of doing that because I'm usually like trying to rush to finish something and I only leave like 2 minutes and I don't do a good job. So that note is taken, and actually that's what I was sort of thinking that maybe I could use Discord or Clubhouse for, do a little bit more Q&A stuff. Okay. Yeah, and Prathamesh is asking about a friction-like force that slows the boy down. It's funny you should ask. That's the next video after Seek. I look at an arrive behavior, and it's not about a friction force that slows it down. It's about rethinking what is the desired velocity. In the case of pure seeking, the desired velocity is always to go as fast as possible toward the target, regardless of how far away from the target you are. But an arrival steering behavior would take account that distance and map the magnitude of the desired velocity to that distance. So you still want to go towards the target, but slower and slower and slower the closer you are, with a velocity of 0 if you are actually exactly on the target. Okay, so I think what I would like to do, my white whale, so to speak, in steering behaviors, it's really queuing at the doorway, but I don't want, that's too much. I have never implemented obstacle avoidance, and Simon has been trying to talk me into doing containment instead. But I kind of, I'm a little bit obsessive, and I don't know why I can't seem to manage to keep all of these pages open. And obstacle avoidance comes first. So in my mind, I need to do it first. And so let's just, if you'll allow me for a moment, I would like to just read this paragraph to see if I can understand it. And I will put some quiet, soothing music behind me while I read it. Not that music. In this demonstration, the green vehicle, I don't see the demonstration, avoids the gray obstacles. The vehicle tries to remain outside of the gray circles while keeping close to its speed limit. The vehicle wraps around the window boundaries. This steering behavior anticipates the vehicle's future path as indicated by the white box. The length of the box is a constant time multiplied by the current velocity of the vehicle. Any obstacle that intersects this box is a potential collision threat. The nearest such threat is chosen for avoidance and is marked with a green boundary. To avoid an obstacle, a lateral steering force is applied opposite to the obstacle's center. In addition, a braking deceleration force is applied. These forces vary with urgency, the distance from the tip of the white box to the point of potential collision. Steering varies linearly, braking varies quadratically. Oops, oh, this is going to be hard. If avoidance fails and the vehicle overlaps an obstacle, the color of the obstacle changes to red. With these parameters and this crowded environment, collisions occur about once every 800 simulation steps. And then different colors are assigned to the... So this, unfortunately, this might be enough for me to start coding this if I had this Java applet running. But I think I want to go over to the paper instead. And that didn't take me there. And look for obstacle, and hopefully there's going to be a diagram. There we go. This is what I'm looking for. I don't know. I'm so like terrified that I'm starting with this. Okay. Now, I'm hearing some ding dings in my ear from being tagged on Discord. So I'm keeping an eye on the chat. Please try to reserve tagging me on Discord for emergency level notifications. Okay. Obstacle avoidance. Obstacle avoidance behavior gives the character okay. So let's look at this. The ability to maneuver in a cluttered environment by dodging around obstacles. There is an important distinction between obstacle avoidance and flee behavior. Got it. Oh, I started reading this to myself. Flee will always cause the character to steer away from a given location, whereas obstacle avoidance takes action only when a nearby obstacle lies directly in front of the character. So this is good. For example, if a car was driving parallel to a wall, obstacle avoidance would take no corrective steering action, but flee would attempt to run away from the wall eventually. So just so I don't spend forever just reading through this, let's take some basic steps here. Let's add the idea of an obstacle class to the world. So I'm going to duplicate this code. This is going to be 5.x obstacle avoidance. And one of the things I like to do while I'm streaming, and let me just click over here for a second, is in the Discord itself. I will paste a link under this live category. Schedule is where I, in theory, post updates about my live streaming schedule. Links is where if I want to share something with you while I'm streaming, I'll put it in there. So I will paste a link now to this base code in case anyone wants to follow along. This will continually update unless I duplicate and make a new version. So it will also be the same link when I finish. But if you wanted to get that right now, that's what I'm starting with. All right, back to here. So I would like to add another file, call it obstacle.js. What does an obstacle class have? Well, it has a position and a size. It doesn't move. It doesn't need any physics. So I'm going to give it an X, Y, and a radius because it'll be a circular obstacle. I mean, we could consider what does it mean to use non-round obstacles, but that seems too hard. But I am going to keep that in a vector. So I'm going to say this dot pos equals create vector X, Y, and this dot R equals R. And then let's just have a function called show, which I draw it as a circle. How's this font size, by the way? I think it's a little bit smaller than what I usually have. No, I don't know. Let me know if it's hard for anybody to see it. This dot X, this dot Y. And Simon is telling me that obstacles are always circles in this particular algorithm. That's good to know. This dot R times 2. And let's give it a kind of grayish color with a white outline. That's a little bit thicker. And I think what I'd like to do, to be honest, is hard code a couple obstacles into the world. Because obviously I want to run this many, many times and always have random obstacles, but it might be useful for me to very intentionally position obstacles to be able to test and debug what it is I'm doing. So let's make, right now I'm just going to make one obstacle, to be perfectly honest. I'm going to put it at, my window is 400 by 400. Let's put it at 300 comma 200, and let's make the radius 50. And then I will have for let obstacle of obstacles obstacle.show. So hopefully now obstacle of obstacles. By the way, obstacle is one of those words that when you start to stare at it, it totally looks like it's spelled wrong. That can't possibly be how obstacle is spelled. Look at obstacles. Put the S on there and it's like, what is that word? Okay, let's try. Obstacle is not defined, so I forgot an essential step here, which is to add it to the index.html file. Oh, it's because I did spell it wrong. No wonder it looks completely insane because I did spell it wrong. How come I don't see that obstacle? Oh, this .pos.x. It's a vector. You know, there's a new thing that I've really liked doing, and that is in the particle system videos. I really like just extending a p5.vector, and I know, I really have trouble figuring out what the right balance between showing next steps and further additions to the sort of foundational ways that I build the examples. And I hesitate to do this because it's going to throw people off. But if you're following along with the nature of code, good news. I'm going to go through why I do this in quite a bit of detail in an entire video. But I can actually have my obstacle extend p5 vector, meaning I don't need to create a separate p5 vector that's a property of the obstacle because it is a vector already itself. Then this is the principle of inheritance. Whoops. Then I can actually say super xy, which means just super is a word that like a parent class is a super class. So I'm saying create a new vector because my parent is p5 vector with that xy, add this concept of r. And then I can just have this dot x and this dot y here. Maybe I should do that also. If I'm doing it there, I should do it with the vehicle, but anyway, I just wanted to point that out for a second. All right, great. We've got an obstacle. I want to get rid of the seek behavior. So I don't need this target anymore for this example. And I don't need to call seek. Let's run this. Let's put the vehicle's initial location at 50, 200. Amazing. Let's give it an initial velocity. And I'm just going to do that manually here. Velocity set 1, 0. There we go. So now I've got a setup here where if I do everything correctly, and I think I might like the obstacles to be drawn first. What did I do wrong here? Come on. Auto format. Did I mess something up here? I don't know. I don't know what's going on. Oh, whoops. What the? This is tidy code. Okay, I don't know what I was doing the wrong key command for tidying, I guess. Very important stuff. So now I've got this setup. I'm doing the easy part first. Right? The hard part is obviously going to be I need to write some code that's like vehicle dot avoid obstacles. And maybe right now, let me just write the function as if there's only ever one obstacle. This, I think, could be an easier way to kind of work this out. All right, and Simon is giving me some nice tips in the Discord with the steps of the algorithm. But I'm going to pull them from the paper. So I need to define this rectangular area in front of the vehicle. Well, I know how I would do this just from a drawing standpoint. That's an easy thing for me to do. And I suppose I might as well layer that in as sort of like a debug draw kind of thing. For example, if I were to say rectangle 0, 0, this dot r times 8, this dot r, which is the size of the triangle. I'm going to write a function called avoid. It takes an obstacle, but it's empty. Right, there's that. And I want to say no stroke, no fill. And then where is that rectangle exactly? It's at negative this dot r and negative this dot r divided by 2. There we go. So sort of problem solved in that I'm able to visualize that rectangle, and even if the particle weren't moving straight, that rectangle is going to be rotated. But I don't think that's really the work here, because the work is defining the boundaries of that rectangle and whether it intersects the circle. I feel like that's going to be very hard. Is it time for my break yet? Almost. Yeah, it is actually. Let's see if I can get a little bit further. Oh boy. Okay. Keep in mind obstacle avoidance, not necessarily collision detection. The geometrical construction of offset pursuit. Opinions consider. Cylinder lies along the character's forward axis. So they're talking about 3D, which I don't care about. Oh, this is very hard to read to myself. I should just read it out loud. The implementation of obstacle avoidance behavior described here will make a simplifying assumption that both character and obstacle can be reasonably approximated as spheres. Okay. So this is actually, I guess Craig Reynolds is describing all these behaviors in a 3D space, and then we're looking at a slice of it. So when he writes that this is a cylinder, we're actually just seeing this sort of top view of it, but I'm thinking of it as a rectangle. So I think I have to just replace. I'm going to do this in 2D, don't get me wrong. But I think I have. That's why I was confused reading this. Convenient to consider the geometrical situation from the character's local coordinate system. The goal of the behavior is to keep an imaginary cylinder of free space in front of the character. The cylinder lies along the character's forward axis and has a diameter equal to the character's bounding sphere, and extends from the character's center for a distance based on the character's speed and agility. Okay. So I'm going to consider the agility fixed, but I could adjust that for speed right now, because ultimately, if there is some distance, like seeing distance, I might call it, which is the magnitude of the velocity times, a factor of 20. And I use that as the seeing distance. And I suppose this width could be related to its agility, but I'm not going to worry about that right now. What is going on with my auto format? Shift tab is not working for me, and it's making me crazy. Oh, it changed. Command Shift F. It used to be Shift tab. I'm going to have to relearn another. No. Command Shift F. There we go. By the way, something that bothers me, and I can't remember if I already filed this as an issue or not, but the web editor will change the scroll of your code when you auto format, and it drives me crazy. If anyone wants to check if there is an issue already filed for the P5 web editor related to that. Okay, maybe nobody else cares. So let's just see this. All right, so let's make seeing distance times 100. Okay, actually I'm gonna make it, it's moving kind of slowly right now, so let's do that. And then, actually I should really put that seek back in, because if I were to just put that seek back in, then I could see it change as it does different things. So vehicle, just as temporarily, vehicle, seek, create vector, mouse X, mouse Y. So you can see as it slows down, that amount that it looks out in front changes. Again, I'm just visualizing the elements of the algorithm right now without actually worrying about implementing them. And I really need to take a break. But where was I? Okay. By localizing the center of each spherical obstacle, the test for non-intersection with the cylinder is very fast. The local obstacle center is projected onto the side-up plane by setting its forward coordinate to 0 if the 2D distance from that point to the local origin is greater than the sum of the radii. Oh, so I can do one of those like normal things. Oh, I really need a diagramming. So I'm going to take a break, and during my break, I'm going to set up this document character because I feel like document camera because I feel like I need to draw a diagram. So give me a second here. Oh, before I take a break though, I would like to take a moment to thank today's sponsor, Curiosity Stream. And coming up over here. So let me start and this is the fun thing that I like to do, which is that I have a wonderful 30-second spot from Curiosity Stream that I will play. But I like to read the narration for it myself. Otherwise, sometimes YouTube copyright strikes it. And so, and people seem to enjoy this more anyway. So I'm going to go to that right now. From the founder of the Discovery Channel comes a new independent streaming service, Curiosity Stream. Home of groundbreaking documentaries and award-winning original series. Follow your curiosity. This is Curiosity Stream. All right, how did I do this time? I feel like I did better last time. But I mentioned this at the top of today's live stream, and you've heard me talk about this before. I am part of an educational group of creators who have teamed up to build a platform where creators don't have to worry about demonetization or the YouTube algorithm. It's called Nebula, and we're partnering with Curiosity Stream. So Nebula has ad-free content and experiments with different kinds of formats. So let me go over to watchnebula.com. And you could start your free trial, or you could pay $5 per month. Or guess what? Definitely don't pay the $5 per month. I mean, maybe you could if you want, but the whole point of this is that you're going to get Nebula for free if you buy the annual bundle with Curiosity Stream, which, by the way, much less than $5 per month. In fact, it's $14.79 after the 26% discount that you'll get from curiositystream.com/codingtrain. And so if you scroll through kind of like the kinds of things that are on Nebula, you're probably going to find all of your favorite creators that you already watch on YouTube. And I'm just scrolling through to show you a few here. Shout them out in the chat. I've been like really interested in following Renee Ritchie's work recently. There's a lot of video essays on sort of movie making and filmmaking. Legal Eagle to sort of learn about the law. Amazing stuff here. Real Science Engineering is amazing. This is the Real Science Channel. Lots of amazing stuff here. Definitely check out Nebula. There's Nebula Originals as well, like Tom Scott's Money. So what does this have to do with Curiosity Stream? So Curiosity Stream loves educational creators like those that participate in Nebula. And they want to support more educational content. So Nebula's worked out a deal. If you sign up with that Coding Train link, not only do you get access to Curiosity Stream, but you also get Nebula for free. And by the way, this is not a trial. You will have Nebula for free as long as you're a Curiosity Stream member. So for a limited time, Curiosity Stream is offering 26% off their annual plan. That's less than $15 per year for both Curiosity Stream and Nebula. So I'm going to go here just to show you how to do this. curiositystream.com/codingtrain. And it should pop up here that you can use. Oh, you can't see that right now. I'll remove the banner. Use the code codingtrain for 26% off. You can also go. I wanted to go to. I'm not logged into my account, but I can go to the click here to get a sneak peek of the library. So this is the one that I was just telling you about that Abe turned me onto, which is called Man's First Friend, a wonderful documentary about sort of the history of dogs within different cultures around the world. And I didn't, Abe recommended it pretty recently, so I only watched a little bit of it, but I'm like, oh, as soon as I have some time to just settle back and get on my couch and relax, I'm definitely checking that out. Don't know what this one is, Secrets of the Solar System, but so many science, music, math, history documentaries here. I've been talking about, I think if I look for the search, it'll pop up. Let me try to find that. Or maybe if let's click on history, and let me go to search, and let me go to Hannah Fry. Yeah, so this is the one that I've been like super obsessed with. Magic numbers, the joy of data, and the joy of winning. I don't know what this one popped up, but maybe Hannah Fry is a guest in this one as well. But Dr. Hannah Fry is amazing. I'm a huge fan. Shout out to Dr. Hannah Fry, and I would definitely recommend these. If you like the coding trade stuff, you'll like those as well. All right, so you're sign up. You'll be soothed by David Attenborough's voice. You can watch Chris Hadfield in the space station, Tom Scott on Nebula, torture your favorite YouTubers. Click the link to get both CuriosityStream and Nebula for 26% off. It's a great way to support educational content, my content. And again, that's the entire year, $14.79. I'll put it up right here one more time. Oops, that's the wrong thing. And then I got to press this button. That's also the wrong thing. I can never press the right buttons. There it is. And I'm going to take a short 2 or 3 minute break. I'm going to set up this document camera so I can diagram figuring out this the math for the obstacle avoidance, and I will be right back. I'm here. I swear I'm here. I'm trying to set up this camera. I guess I can, let's see. I plugged it in. I've got it in position, but I don't know if it's working yet. Let me turn off studio mode. Go to me here. And let's see what happens. I can close this. Boy, I thought I could do this in 5 minutes with no problem. I connected a microphone. No, I don't. It's still this microphone though, right? Yeah, okay. Let's see. Don't know what's going to happen. I probably should preview this before I turn it on. Hello, there's me in my green screen. Nope, not that one. This one. There we go. Oh, look, there's my hand. Oh, I scrunch your face. Okay. Okay. Let's see here. That's probably better. And then let's crop this off and crop this off. Move it over here. And let's move it below a few things. And we don't need the banner here right now. So that'll do. If I have a pencil. Will you be able to see? Oh, let me turn the light on. How come that light doesn't go on? I think it's not getting enough power. Oh, that's not the light. That's not the light. There we go. Is that better? Whoa! Oh no, it's doing the thing again! Why does it do that? That's why I forgot why I wasn't using this. I was like, why did I unplug this thing and don't have it set up anymore? Because it doesn't work. Hold on, everyone. Let's see if I can get it to. Let's see if I can get it to work. Okay, there we go. I don't know why it's not focusing. Should autofocus better than that. Yeah, Austin is saying that I need a drawing tablet. I don't know why I'm so opposed to the idea of using a drawing tablet. I think I've just had too many bad experiences with weird latency, and I think all that stuff has been sort of worked out probably with, newer tablets and Apple Pencil and all that stuff. I'm not in the space where I have the whiteboard, which is why I just don't understand why. Oh, I forgot that as soon as I move it around. All right. This is so sad. This is pathetic. Welcome to the Coding Train, where you watch a person who's really ill prepared to live stream. I'm going to try this one more time. All right, am I back? By the way, restarting the computer seems to have kind of resolved this issue. Look how beautifully clear this is right now. So maybe I just needed to restart. So thanks for your patience. I do not have the chat open right now, so I cannot see your chat messages. Let me take a minute to do that. If you will bear with me. Restore pages. What's the chance? Oh, that's beautiful. Okay, I am back. My pages are restored. And we're back as if nothing happened. All right. Back to this diagram, which I will now move over to here so that you can kind of see it. Let me hold on. Move this over, give myself a little bit more room to do that. Okay. All right. So now, the idea is that I have a circle. It has some radius r. I have a vehicle which has some velocity, and I've projected out some sort of area in front of it. So I think what I need to do is consider this a line, and I need to get the normal from the center of the circle here. And if this point is closer than whatever this distance is, and within, and this distance is minus, and this distance is less than the radius, then I'm in danger of running into the obstacle. Sorry. So in other words, I need to use this concept of, I have to look at lots of other pages are full of stuff. I need to use the concept of scalar projection, which is that if I have a vector, and then I have a point, how do I find from that point the normal to that vector? And I have done this, oh, and you can't really see that. I have done this in, I do exactly this in the pathfinding example. And what I'm getting. Okay. Now, let me, do I have a button to open and close the overhead camera? I'm just going to do it manually. Okay. Hold on a sec here. Okay. All right, let's work on this idea of the scalar projection idea. Okay. Sorry, I'm a little flummoxed here. Okay. I don't know if all that work was worth it just for me to like draw that little diagram. But if I go to the nature of code, I work this idea out here for path following. So if my vehicle is here and like, I'm doing this is slightly different. Yeah, this is the path of the vehicle. Okay. So I'm doing this in a slightly different way, but it's the sort of same idea. Okay. So I'm thinking through this. So let me try to actually do this without the vehicle moving for a second. Okay. There we go. So I don't want the vehicle to move. So let me take out this seek. And let me have the vehicle not call update. There we go. And let me set its velocity to something like this and something like this. Okay, that's a little bit extreme. Okay, so this looks good. Like I feel like I kind of want to just. All right, so basically what I want to do is I want to find this, this point. If this is take the bottom of this rectangle, consider it a line. I want to find where the center of the circle connects to that line. And I've done this before, but I'm having kind of trouble thinking of how to do this. And Simon is reminding me that I have get normal point as in the path following. Get normal point. So this is that function. Let me just grab it. It's written within processing code way. But let's put that into, I need to be in the vehicle class in avoid obstacle. So let me just paste this generic function here. And it is a function to get a normal point, to have a position. What's this? And then, what's A and B? Oh, the line between 2 points. Okay, A and B. And just translating this to P5. Sorry, I will get back to explaining what I'm doing in a moment. I just want to get this code in here. And this is there. All right, so this is now my get normal point function. And let's bring the avoid obstacle function all the way up to here, just so I can kind of see it closer to this. So what are the point is the center of the circle. So get normal point is, so the position is the obstacle, And I'm going to be writing extra code right now that I don't necessarily need. So just to be clear, if I go back to my diagram, I'll explain what I'm doing here, which is that this is now that position that I'm talking about in the code. That's this. Like imagine that's the center of this obstacle. Then the vehicle, I have point A and I have point B. This is point A. I realize you can't see it because I'm doing like the worst job ever. And then over here, you can't see that, is point B. And my function that I've written previously, if I give 2 points, I get this vector. And then if I give it a position, I get this normal point. Now, I don't actually need to do these 2 points because ultimately I already have the vector in the velocity. But I think just to like get it working, let me do it this way first. So I have to move that away. And so now A is this dot position, and then B is this P5 vector dot add A, and then I need to add the velocity to it. So like seeing distance should be, maybe I need to make that. So I should call this seeing factor. And that's 50. Because ultimately, and again, this is totally silly that I'm doing this, but I'm going to do it anyway. Add A plus, I'm going to copy the velocity and multiply it by the seeing factor. I think I'm doing way too much extra stuff here, but I just want to understand all the pieces. So I want, once again, this is A, then I want to get B, and then I have pause, and I want to see that it just gives me a point here. So add that, and then the normal should be get normal point, pause A, B. Is that the way that I define this function? Pause A, B. And then let's draw fill 0, 255, 0, ellipse, normal.x, normal.y, 16. We'll make that a circle. Okay. So let's see what this gets me. P is not defined. Where? Line 2. Call this pause. All right, that's promising. Seeing distance is not defined, line 66. Seeing factor. Yeah. So, gotta put that back in. I mean, I'm doing a lot of redundancies here. Come on, why am I not seeing this rectangle? Oh, multiply. What? Ah. Oh my goodness. I've lost my mind here. I've forgotten what it is I'm even doing. There we go. Okay. So that's the point. And I think it would be useful for me. First of all, I meant for that to be red. I don't know why I meant for that to be red. Make it a little smaller. And then I would like to draw a line, normal.x, normal.y to pos.x, pos.y. Okay. And no stroke. Stroke 255. And that line, this is so silly, but I can't stop. There we go. So this is the idea. Now I've made this look kind of weird because this dot is like I positioned this perfectly, but let me actually go now and have the circle, the vehicle move around. Like I'm going to add back in the seeking. Oh, and the update. Right? Like no matter where I am, I'm always getting a normal. And when that normal is inside that circle, I'm going to hit the obstacle. The normal is even behind, right? Because it's just taking that line. So I can check. All right. This is good. Now, let me see if I can reduce what I'm doing here in the vehicle. Like I actually don't need A and B because I could just start with a vector. And that's this. And then why do I even need to normalize it? Do I? Oh yeah, I do. Okay, then I can normalize it. So this could be then get normal point position and this dot velocity copy. And I don't need the velocity or A and B. Like that should work as well. A is not defined. Oh, I need this vector though. I do need A, which is which was what? The vehicle's position. Right? I don't have a lot of space for my code here. I don't like the way that I'm doing this, but these are the three things I need. Right, get the normal point with the position. Oh, no. Oh, yeah, the obstacle. Yeah. So I don't need a separate variable here. I might not need to copy all these vectors. So the idea is that get the normal point. I have the vehicle's position, the obstacle's position, and the vehicle's velocity. AB is not defined because that's whoa, that is I'm so confused now. That's V. Oh. Was it this and I wasn't paying attention? I'm so confused. I'm so confused. I got to get my normal point function back. Oh, I have really screwed this up. I had it working and I tried to simplify it and I lost my thread, and using somebody I think is noting that using the using A and B as variable names is making things worse. Okay, hold on. Everybody, relax. I've got this. I've got this. Agents, path following. Let's go to this one. Yeah. Vehicle. Do I have get normal point? Let me grab this one. So basically, I had position A. I don't need B anymore. Instead of B, I have that vector. So AP is still P minus A. And then V is now this, AB. So V dot normalize. V dot multiply AP dot V. Okay. Yeah. Normal point A add V. Okay. Where is pause is not defined. Line 36. There we go. Okay, so I've got that back. I mean, it's sort of the same. And do I need copies of all of these vectors? Because the velocity gets normalized. P just gets used here. So that doesn't need to be copied. But I'm going to leave it as is. Okay. Okay, so now I want to know if it's going to hit the obstacle or not. So there's a few different ways I could do that. One is if it's going to hit the obstacle if that point, the distance between that point and the circle, right? So if I take the distance, P5 dot vector distance between the normal and the obstacle, if D is less than the obstacle's radius, and I know I need some kind of like agility buffer, but I'm just going to leave that right now. Then let's make this much larger and let's fill it red. Otherwise, make it green. So let's see if now it should turn red. Where do I have obstacle? Should turn red. Yeah. Anytime it's within the circle, it's going to be red. Now, also, beyond just being... And I really feel like I need a much larger space to work with than 400 by 400 pixels. So let me make this. Okay. All right. Okay. Great. Now that's good. Okay, so if I want to consider the sort of buffer, the size, thank you for Simon is giving me this suggestion in the chat. I can fix that as if it's less than the radius of the obstacle minus the extra buffer of the of the actual size of the triangle itself. And I guess that's half of that radius. But I don't know that I need to worry about that right now. I can figure that out later. Okay. Let me give myself a little bit more room here. There we go. Okay. Now the other issue is, let me get my diagramming back. This is so not the way I like to do things, but actually, let me just raise this up a little bit, and hopefully it's not gonna... it did the thing! It did the thing! Don't touch the camera, Schiffman! Hopefully this whole stream doesn't crash. Apologies in advance if it does. Switching camera. Switching back. Come on. Oh boy. Oh boy. Oh, this overhead camera is the worst. I'm just going to get rid of it. I'm just going to get rid of it. There it is, all frozen and not in focus. And Austin's saying, shouldn't you fix it so it doesn't detect a potential collision when it's moving away? Exactly. That's what I want to do right now. But I was going to try to explain how I was going to do that with the diagram, but that's just a fail. I'm going to give up on the diagram, everybody. So I need to use the diagram for myself. I can show it to you this way. So basically, let me create the scenario where if it's moving in the other direction, yeah, basically, why it might be useful for me to have those 2 points is I need to check to make sure that other point is actually in that line segment. I do this in the path following as well. Right? It needs to be that point. Like it shouldn't be like, it shouldn't be red even here. Like, hold on. Let me turn off the seeking and go to the particle and have its initial velocity be, once again, 1, 0. It should not be red right now. It should not be red until that rectangle reaches. So also that point should be within the rectangle. So how do I do that? The normal point, oh, I know. It's just got to be less than the seeing distance. Okay. But also has to be in the right direction. All right. Okay. A couple things. So particle in a void. So if it is there and okay, so what is D1? Oh, I'm doing a terrible... See, this is why I have to work stuff out. I mean, maybe there's a way for me to be thoughtful about my variable naming while I'm working it out. But D1 is the distance between the obstacle and that point. D2 is the distance between the normal and this position. So I'm just, for simplifying, I'm going to take that out again. And D2 is less than seeing distance. This is driving me crazy that seeing distance is just the velocity's magnitude. I'm going to have this be a fixed variable for right now. Okay. I'm going to make it not scale. It's going to be much simpler for everybody. So I'm not going to worry about scaling it according to the magnitude. I can worry about that later, just to simplify things. Basically, it needs to both be within the circle. That normal point needs to be within the circle and not too close to the vehicle. Oh, having a whiteboard would be so great. Seeing distance is not defined. Line 79. So as soon as that rectangle touches the circle, it should turn red. No! Oh, weird. It did, but it seemed to be like late. I wonder if this is a function of it being like perfectly aligned with the center. Like, let me just, for a second here, go to obstacle. no, sketch. I'm gonna make this obstacle much bigger and a bit further down. Yeah. Why? I'm getting the wrong distance. Clearly, I'm getting the wrong distance. Normal and this dot pos. That's the right distance. And I'm drawing. Oh, I am offsetting it back by negative this dot r. So the seeing distance is actually offset to the back, not the center. It's because of the triangle. Oh, that's kind of silly. Let me not offset it back just for a second. Is that enough to like get it off that much? Yeah. No, it should actually be earlier then. Oh, no. I'm not thinking about the edge. What am I doing? I need to project that out to the edge. Oh, this is weird. I'm reading the chat right now. Okay. So actually what I want to do is just check that. I think I want to check something completely different. For example, I want to check the distance between the position plus, okay. So if I have an endpoint, which is this dot pos dot copy dot add. Oh, this vector math stuff is kind of crazy. Do I have a copy of the velocity? No, never mind. This is silly what I'm doing. P5 dot vector dot add this dot pos this dot velocity dot copy set mag seeing distance. Is that actually right? Add, I want to add the position and the velocity with its magnitude set to the seeing distance. And then the D2 is the distance between the end and the obstacle. And as long as that is also less than obstacle.r, right? Is this, this would let me know where the end seeing distance is not defined, this dot seeing distance. Right, this would let me know if the end is within the circle, yeah. Okay. So if it's along the path to the circle and the end is sitting then. All right, so that's kind of right, I think. Let's turn its velocity a little bit. Just to see, like, what if I set it to 3, negative 1? Right, it's never going to do that. And then if I do it negative 0.5. Yeah, okay. I think I'm in pretty good shape here. Oh, but what if it's going in the other direction? So the question is, if it's going in the other direction, it can't be negative. How will I account for that here? I could use a suggestion. Hold on, I have to check my messages. Oh, okay. I see somebody running the applets. That's exciting. Okay. Okay, so now there's like one little piece to this, which is that if it is going in the opposite direction. So let me determine, let me create a scenario where it's doing that. So its initial position, what if I make its initial position like over to the side, and then have it going the other way. Okay, hold on a sec. How do I test for this? Let me have the obstacle and have the vehicle further up. Is it? I guess it's just going to work because that distance is too far. Okay, it knows. It knows. It's a little, I don't need to add anything. It's a little messed up that when the edge goes out, but hopefully it's never going inside the thing in the first place. Okay, so there's some massaging that needs to happen here, but I think I mostly have the right idea, and I should be able to, if I steer it around, right, we should see, and let me give it a much bigger seeing distance just to, and make the obstacle a little bit smaller. Which should help me. Oh no, why? What happened? I mean, oh, because what if the seeing distance is on the other side of it? So it's not actually, it's anywhere within that, but that seems like a fine-tuning thing. How there's got to be an easy way to resolve that though, right? Because otherwise it's mostly the right idea. Okay, I'm going to move on. Yeah, that's a good correction that I'm getting in the chat here. Okay. Why not check intersection of the circle with the current velocity vector? Yes, that's what I want to do. Oh, like cast a ray. Oh, that's what I should do. And then just check if wherever it intersects is less than, oh yeah, that's much better. So let me just put a to do in here because I want to kind of move on. I didn't necessarily expect to finish this. I did expect to get a little bit further. So to do, look at casting ray for vector plus circle intersection. I mean, wouldn't that just save me a lot of trouble in the first place? Do I even need that normal thing? I'm so confused. Okay. Okay. Rectangle, circle, collision detection. Right. I could also use a collision detection library, as Fun Planet is suggesting, but I am trying to avoid that. Let's just go back to the description, and I want to at least introduce the steering behavior. Okay. By localizing the center of each spherical obstacle, the test for non-intersection of the cylinder is very fast. By the way, I should have kept reading because I think that's giving me some better way of doing this. If the 2D distance from the point is the greater than sum of the radii on the character, then there is no potential collision. Yeah, I think I could have definitely done this a different way. I realized I went down a kind of strange path. Similar obstacles which are fully behind the character or fully ahead of the cylinder can be rejected, can be quickly rejected. For any remaining obstacles, a line sphere intersection calculation. Oh yeah, line circle intersection calculation. So that's what I should be doing. Like, yeah. Like this is enough. So this actually right? I'm going to leave this in here, but I should do this in, this should be a line circle intersection. And now, okay. Steering to avoid this obstacle is computed by negating the lateral side-up projection of the obstacle center. What the hell does that mean? Negating the lateral side-up projection. In figure 7, obstacle A, does that mean like have a steering force that points in this direction? Obstacle, okay, you don't know where I lost where that is. I'm like lost that spot. There it is. I couldn't find the text. This like big wide block of text. It's very hard for me to read. This intersects the forward axis near the character. Okay. Steering to avoid this is obstacles B and C do, but B is selected for avoidance, and its corrective steering is to the character's left. The value returned from the obstacle avoidance, the steering value to avoid the most threatening obstacle, or if no, a special value null or the zero vector. So is it literally as simple as just doing a vector that is perpendicular to its velocity in the, like just steer away? Is it that simple? Because then it would be a matter of like, so this is like, if it's red, then this is like apply the steering force. And so that force would be copy of the velocity, and then velocity, like I could rotate it by 90 degrees, but how do I know which way to rotate it? Well, I want its direction to be the same direction as, okay, so actually, this is simpler. P5 vector, subtract the that endpoint from the endpoint minus the obstacle. That's a vector pointing out, yes. Force dot set mag. Do I have a maximum force? Yes, max force. And then this dot apply force, force. So let me get rid of the seek. Let me also add an edges. And I will, or I could seek. So Simon is saying it's a flee behavior. So I could flee the nearest intersecting circle. Yeah, I think it's not actually what I want to do though, because I don't want to turn around. A flee behavior would cause me to turn around and run in the opposite direction from the circle. And what I just want to do is just steer away until I'm not going to hit it anymore. So I am going to say vehicle edges. I also I need to wrap the edges. So to add an edges function, if this dot pos dot x is greater than width, this dot pos dot x equals 0, else pos dot x is less than 0. And I should be taking r into account, but I'm not bothering to. Let me do that with the y. And this, by the way, I've got to finish it, wrap up here. So I'm hoping this kind of works for just avoiding the one obstacle, and then I'm going to clean up this code, work on it some more, try to write up an explanation, think about making a video on it, and all that jazz. Okay. So, max force is not defined. Well, that was good. Where did I, line 50? All right. So Not a lot to see here because it's like super overpowered in terms of its steering, and I'm not taking into account the size of that rectangle. So let me do that. So I kind of want to have an agility. So if D1 is less than, no. D1 is the distance between the normal and the obstacle. And so if D1 plus or minus, if D1 my brain is hurting. I need to use my paper. Sorry, everybody. So this distance is less than this distance, and if I take off that obstacle, yeah. If I take off that as well, that'll give me a more, it should steer further. Oh, no. Didn't I rerun this? All right, hold on. Let me put things back. Like, hold on. I just want to see something. Like, what if I make this really big? Why? Okay. So I'm confused why I'm not getting the... Oh, it's plus. Right? No, it's definitely minus. It just was such a tiny amount that I'm not noticing it. Oh, am I suffering from the thing being too far out past it then? I think I am. It stopped steering when... So I'm going to have to make some improvements to this. But I've got the basic idea of my one obstacle. So yeah, so let's... I mean, it's not very exciting to look at because it's just kind of avoiding the one. But I want to do a couple things. One is just to like have this demo a little bit in a little nicer shape here. And I want to go to sketch.js and I want the vehicle to do this. And I want it to start at 0, 150, 200. I want the seeing distance to be much smaller. It should actually be scaled according to its velocity. Let's make it 100. Okay, so let's see what happens here. That's good. That's what I wanted to see. I definitely need it to move faster if I'm gonna like be able to sort of see how this works. Because I would love to introduce obstacle avoidance into the flocking system. It'll be really cool to see that. Okay, so this is doing what I wanted to do. Farouk is saying, check the diagram on the page. You will see 2 blue tangents. Steer until the direction of the motion has tangents on one side. So I'm going to be setting this aside now. I'm going to save this, and I am going to accept all new versions of this that correct my errors and clean things up. I'm going to have to, I definitely going to need to work on this more on my own. Like, this is not super interesting to watch without multiple obstacles, without multiple vehicles. But I think this is kind of as far as I'm going to be able to get with this project today. I think my kids are still out on a walk in the park, and I want to go meet them. So I'm going to play my goodbye song where I will So stay tuned. Don't worry. This is just... Oh, I don't have my music hooked up. What is going on here? Hold on a sec. We're going to fix this. Because I forgot that I restarted my computer. Oh, you are hearing the sound. I'm just not hearing the sound. Is it super loud? Okay, great. Thanks for everybody for tuning in today. It's very loud in my ear. Maybe that means it's too loud in your ear. Simon, thank you for all your feedback. I'm going to work on correcting this later. So this is going to be incorporated into Chapter 6 of The Nature of Code. If you're kind of joined late wondering what I was doing, Chapter 6 of The Nature of Code goes through all of these different steering behaviors as implemented in P5.js. And I never have attempted to implement the obstacle avoidance one. Really, ultimately, the reason why I'm doing this is I really want to implement obstacle avoidance along with... I just don't know how to get this to run immediately, but I guess I'll just stick with this. Hopefully this example is going to pop up and run in a second. Yeah. So I would like to introduce obstacle avoidance into this flocking system because I think it would be really cool to see them like flock around the obstacles. But I'm far, far, far away from that right now. So I've got about a minute left to answer any questions. I can't remember who it was who suggested I do more Q&A stuff, and I do a very poor job of just trying to catch a few questions at the end. And thank you to everyone who's been helping. I see that Joseph in the Coding Train Discord has gotten the Craig Reynolds applets working. I'd love to know how you did that. Maybe we can collaborate on a little web page that just has like that captures each one of those demos running for like 30 seconds and puts it in a little like GIF animation, because I would like to be able to refer to those often. I should mention, let me pause here. So it's actually going to be a little while until I'm back in live streaming. Many, many videos are going to be continuously coming out on the Coding Train. I've actually also been redoing the Beginner Learn to Code P5 videos. So if you happen to be here, you probably aren't here right now if you're like a totally new coder, new viewer to the channel. You might be a new viewer to the channel, but if you're a new viewer and you've never programmed before, please come back. Well, stay, but also come back because the code playlist, which is this one, I have now new versions of all of these 2.x videos, which are about variables and the random function in P5. These are all from several years ago. So I have new updated versions of those. Those will be coming out. I have all of Chapter 4 coming out. I have to make and have all of Chapter 6 to come out. So all this is going to be coming out in the next month, but I won't be having any live streams from now until after April 10th. With one exception, on March 19th, I am having a guest who does live coding performances come and talk about that practice of live coding. So stay tuned, sign up for the Discord, follow me on Twitter at Schiffman, subscribe to the channel and click the bell stuff if you want to like get notifications of when that next live stream about live coding performance is coming. Yeah, and stay tuned for all the new stuff. What else do I have to say? Yeah, Dabbing Bear writes, I just tried to play the video at 2x speed like I usually do and didn't realize it was a stream. I love it. Please watch my videos at 2x. I don't know how they're tolerable unless they're at 2x. And so I'm gonna go. I've got to run. Thank you. I'm sorry that these streams like don't wrap up in like a sort of thoughtful like end of the show kind of way. I just kind of like jump off. But that's unfortunately what I have to do today. I'm going to be working on this particular example more and seeing you all in future videos on the Coding Train. I would love to hear any feedback from you. Just another last little plug. if you've worked on anything related to any videos in the coding train, like for example, I noticed somebody on Twitter shared with me a spring a spring project they made based on this. Please add them to the website. And we're really trying to fill out the website with lots of community contributions. Got new ideas for how those are all going to be organized and featured coming soon. Thank you, Austin, for posting the link to CuriosityStream. It's very appreciated. You can sign up again at curiositystream.com/codingtrain for 26% discount off the entire year. It's $14.79 for the entire year, and you get Nebula for free. Okay. See you all, and on the next time on the Coding Train. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot. This dot, never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. And I'm gonna say once again, here we go. Sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that, and look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens, 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 kittens and kittens and kittens. Kittens and kittens and kittens and kittens, 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 kittens and kittens and kittens and kittens. I feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Stream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorn.
unicorns and rainbows and cupcakes. That was invalid syntax. I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. First thing I need to do is, yes, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. Kittens and kittens and kittens and kittens. Kittens and kittens and kittens and kittens. Kittens and kittens and kittens and kittens.
Thanks for watching, everybody. I usually often turn my camera back on at the end here, do a little dance, but I've already unplugged it. So see you all next time on Coding Train. Have a wonderful day. I'm going to go spend some time outside. If you're able to, I highly suggest you do as well. Stay in touch, and till next time.